All right, so the next unit is on something called systems of linear equations. All right, so in this first lesson, what we're going to be doing is basically coming up with these uh, these systems. So yeah, we'll be translating kind of word problems into equations. All right, so that's this first lesson. All right, so yeah, so the title is Developing Systems of Linear Equations. All right, before we do that, or before we get into the first example, just yeah, definition of a linear system. All right, so a system is when you have two or more equations um, where the highest power of each variable is one. Okay, so this part here, highest power of each variable being one, is the linear part. Okay, so linear means highest power of x, highest power of y is one. Okay, so yeah, each variable, this is like x and y. All right, so yeah, so highest power of x, highest power of y in your equations can only be one. All right, so let's take a look at the first example here. So the perimeter of a rectangle is 20 centimeters. The length is 4 centimeters longer than the width. Okay, so what we want to do is we want to translate this into a system or into two equations. All right, so yeah, so part A here, we're going to create a linear system to model the situation. All right, so just to help here, what I'm going to do is I'm just going to draw a little diagram here. So we got a rectangle. And for this rectangle here, you can see that we'll label this side the width, this side the length. So if it's a rectangle, that means that this side is equal to this side. So this is also the width here. And likewise down here, the length. All right. So next thing here is the perimeter of the rectangle is 20 centimeters. So the perimeter is the distance around. All right. So looking at this diagram here, I know we don't have the actual measurements, but we know that the total distance around is 20 centimeters. Right, so what that means is that if I added up the width to the length to the width to the length, that's got a total up to 20 centimeters. So in other words, the first equation that we can come up with here is that two widths, because there's two of them here, plus two lengths must equal 20. All right, so that's one of the equations. The next sentence here, it says the length is 4 centimeters longer than the width. All right, so what this does is this actually gives us a second equation for this problem. So let's think about this. The length is 4 centimeters longer than the width. So that means the length so whenever you see the word is, you can just put an equal sign there. Okay, so the length is 4 centimeters longer than the width. That means that if I take the width, I got to add 4 centimeters. Then it will be equal to the length. So hopefully that makes sense, right? So yes, since the length is 4 centimeters longer than the width, if I take the width, add 4 centimeters, it's got to equal to that. All right, so in order for it to be equal. All right, so this is the system. So this is what we call a system. And basically what happens is you have two equations here. And two variables. Or two unknowns. Right? But I'll call them variables. And so that's x and y. All right. So whenever, or sorry, x and y. Please forgive me, I didn't use x and y here. I used length and width, right? So let's go with L and W. All right, so these are my two variables here. So I have two equations with those two variables. All right, cool. All right, so now the second part of this example, it says that verify that the length is 7 centimeters, length is 7 centimeters, and the width is 3 centimeters. All right, so what that means is that we want to verify that this is the actual solution to this problem. Now, to do that, basically what we need to do here is we need to plug these values in for the two variables. And we're going to plug into both equations and check that they are both true. All right. So I'm going to go back to the system that we came up here. So we got 2W plus 2L equals 20. So 2W plus 2L is going to equal 20. And the second one was that L is equal to W plus 4. Okay, so in order to verify that we have a solution, these values here, right, the 7 and the 3, the 7 and the 3 are both true for both equations. All right, so what that's going to look like here is in the first one here, I'm going to plug in. Let's use a different color. So for W, I'm going to plug in 3. So just plug that in there. And then for the L, plug in 7. And we're going to make sure that this is true. All right, so 2 times 3 is 6. And 2 times 7 is 14. And 6 plus 14 is 20. So we get 20 equals 20, which works. All right, so we verified the first equation. But in order to be a solution, it's got to be true for both. All right, so I'm going to plug in again on the second one here. I'm going to plug in 7 for L. And then I'm going to plug in 3 for W. And we do get 7 equals 3 plus 4, which is 7. Okay, so when you're asked to verify a solution, you're going to plug that in for the variables and make sure that the equations are equal on both sides. Cool. All right, let's do the next example here. All right, so this time, the store sells red t-shirts and blue t-shirts. Red shirts cost $10 each, blue shirts cost $12 each. The store sold a total of 20 shirts one day with a total revenue of $224. All right, so we want to create a linear system to model the situation. All right, so again, we got a couple things going on here. All right, so we got red shirts and blue shirts. All right, so to model the situation, first thing I want to look at here is actually going to jump to this one, a total of 20 shirts. All right, so if R is the number of red shirts, and I add it to B, which will represent as the number of blue shirts, right, that's going to equal 20. So if I take the number of red shirts, add it to the number of blue shirts, that's going to equal 20. So that's going to be my first equation. Now to get the second equation, it's going to involve what they call the revenue. All right, so revenue is the amount of money brought in with the sales. All right, so if red shirts cost $10 each, if I take 10 and multiply it by the number of red shirts sold, so let's say R is the number of shirts sold, this should be the total amount of money that's brought in from selling the red shirts, right? So for instance, like if I sell 2 red shirts, I'll plug in 2 for R, 2 times 10 is 20, so $20, right, would be the amount of money that the red shirts brought. Hopefully that makes sense, right? So I just take the price and multiply the number sold, to give me the amount coming in for the red shirts. And likewise, since the blue shirts are $12, I'm going to go 12 times B. And so the total revenue here is going to be $224. All right. So, and I'm just going to write where R is the number of red shirts sold, and B is the number of blue shirts sold. All right, so yeah, so hopefully that makes sense. So let's just kind of review these 2 equations again. All right, so if R is the number of red shirts being sold, B is the number of blue shirts being sold, Now, if we take the number of red, add it to the number of blue, that's going to equal 20, because there's a total of 20 shirts sold. Now, the second one here, this is $10 per red shirt. If I take 10 and multiply the number of red shirts sold, that should give me the revenue for the red. Likewise, if I take 12, multiply it by the number of blue shirts sold, that should give me the revenue from the blue shirts. If I add the two revenues together, it's have a total revenue of $224. Okay, so these are my two equations. So next up, we want to verify that 8 red shirts and 12 blue shirts were sold. All right, so again, I'm going to take these values here, plug it into the two equations, and make sure the left side matches the right. So let me just copy down again the two equations. So R plus B is equal to 20. And the second equation was 10R plus 12B equals, I believe it was 224. Yep, 224. So 224. And so let's plug in. All right, so let's plug in, let's see, 8 red shirts, so 8. Then we had 12 blue shirts. It's going to equal 20. 8 plus 12 is 20. So 20 equals 20, which works. All right, and for the second one here, 10 times, again, the number of red shirts we're saying is 8. Then add it to 12 times the number of blue shirts, which was 12, equals 224. All right, so let's check this out. 10 times 8 is 80. 12 times 12 is 144. And 80 plus 144 is 224. All right, so this works as well. Right, so that just verifies that this is the solution. Cool, guys. All right, so yeah, so that's basically it. All right, so for this lesson, basically the main thing is just translating words or word problems into equations. All right, and then the second part, where you're asked to verify, you just, with the answer, you just plug them into the variables and make sure the left side matches the right for both equations. Cool. All right, guys. So yeah, so that makes sense.